Nice. Yeah, actually, this reminds me of Vitalik's writing about making Ethereum cypherpunk again. And he mentioned various parts of the stack, right? And of course, from like the banking to the receipts to, of course, the DNS, the email, the sign in with Ethereum, and then of course publishing and social media and so on. Yeah, so now we're starting to touch on many parts of the stack. Actually, where would we say Lit stands in that cypherpunk stack, so to speak?
I mean, I think it is really a deeply cyberpunk project. It answers a philosophical question that has been kicking around in certain circles for years, which is, can the internet keep a secret? And basically we're saying, yes, here's how.
Hello, everyone, and welcome back to the Web3 Native Podcast. Now, kicking off the new year, we have an exciting guest and a really exciting new protocol that is about to make some major announcements and launches. We have David from Lit Protocol. Hey, David.
Hey, thanks for having me. Delighted to be here.
All right, and we've known David for quite some time, quite a number of years actually, since the accelerator days, and Lit has been making so much progress. Why don't we go back a little bit to the beginning, David, and let's do a very quick intro, the usual, of yourself, and let's try to break down Lit, because I know sometimes it's a bit hard to understand for most people.
Yeah, absolutely. I'll introduce myself first. My name is David Snyder. I've been around the tech startup space since the end of 2013. Was on the founding team of a B2B SaaS business for several years that was acquired by LinkedIn at the end of 2017. But during that period, I was in San Francisco in the 2014-15 era and exposed to Bitcoin, bought Bitcoin. But what really kind of lit a light bulb up for me was reading the Ethereum white paper and being able to discuss that with friends, and just the vision of the future that was possible became clear and continues to become more and more clear from that point. And then so in the start of 2018, I teamed up with my current co-founder, Chris Casano, and we spent several years what they call navigating the idea maze, looking for a place where we could really make a impactful value. And then in February of 21, so kind of 3 years ago from today, roughly, we were thinking about, where does key material get stored in decentralized systems, in the decentralized network-driven world that we move closer to and are in every day. And kind of almost as an offhand comment said, well, what if we use a network of nodes to manage key material? And functionally, at its most basic level, that's what Lit is. It is a distributed key management network. Now, what is key management? We could start to define that, so you could get a better sense of this. So if you think about like Web 2 equivalents of key management, there's a publicly traded company called HashiCorp. They do key management for enterprises. Folks like Amazon and Google offer what they call KMS, a key management store, as part of their compute offerings. Of course, both of those providers are centralized. We also have key management inside of the crypto realm. With the introduction of blockchains, there's a new need for storing keys. So folks like Coinbase, of course, and any other registered custodian is managing keys on behalf of the user. But the big insight that we have, and the invention behind Lit Protocol, is to have a key management system that is leaderless, where the parties, the node operators, are all managing a part of the key called a key share in the technology that we use, which is known as multi-party computation threshold secret schemes, often abbreviated as MPC-TSS. So you can think about each of the nodes holding a part of the key that is a part of the whole. And so when somebody wants to generate a signature, for example, to send one Ethereum from Alice to Bob, Alice says, hey, I'm Alice, and proves that she's Alice through some authentication method, like signing in with Google or whatever it might be. the nodes are all independently verifying, is this user actually Alice? They're checking the token or whatever the auth material might be. And then once they pass, each of the nodes create something called a signing share. You could think of it as like an authorization, and they send that back down to Alice. Alice collects those shares on her computer, and once she's collected enough of those authorizations, she can use that to essentially sign that specific transaction to send those funds from Alice to Bob. And so the mental model here, if you're have like a familiarity with how torrenting works, where you're like collecting little bits of media such that you can watch a video or read a PDF on your machine, here you're collecting little bits of authorizations from these key shares such that you have the full signature on your computer. But you don't actually have the full key. That's a major security aspect. The full key never leaves the nodes. You just are being sent the authorizations. And so that's the signing side. And so I'm sure we'll get into some of the use cases around that, around people using that for cross-chain messaging, for oracles, for wallets, for verifiable credential issuance, for DeFi automation. The other thing that cryptographic key pairs can do, asymmetric key pairs, public key cryptography can do, is encryption. And so most people have a sense of like using Signal app or WhatsApp for sending encrypted messages, which is really great when you have both parties online at the same time and they can do the handshake to send one another private messages. But there's also cases where somebody wants to have a rule or a condition or a program around who can decrypt data. And LIT, as a distributed programmable key, can basically read rules and provision decryption rights to data in the same way. And so that has another set of use cases that are really exciting, like access control, licensing, Web3 social media, data marketplaces, and we can definitely talk about some of those. So in short, just to bring it back together, it's a distributed key management system. And I guess for a little bit of historical context, the reason that we think this is like so vital and so important, other than the feedback that we get from our ecosystem partners and friends and fellow builders, is if you go back to the first document of this industry, the Bitcoin white paper, in the abstract, Satoshi's first sentence is, we need peer-to-peer cash. The second sentence is, digital signatures provide part of the solution, but we also need blockchains. And then the rest of the paper is about Bitcoin and proof of work. But right in that second sentence is a big insight, which is that from like an abstract sense, there's really two concepts that make digital ownership something that is possible in our world. State, which is blockchains, and signing, which is keys. And so what we have been doing for the past 3 years is essentially taking the design principles of blockchains, which is to make systems that are distributed and fault tolerant and programmable, like in the case of Ethereum and many other programmable blockchains, and applying those design principles to the world of key management.
Perfect. Thanks, David. Okay, let's try to kind of summarize it even further. I think, as you said, key management and decryption as well. Now, one might wonder that, look, like you said, it's already in the Bitcoin white paper, and with blockchains, and anybody who is interacting on chain is used to having private keys, having a wallet, signing transactions already, or sending transactions also. So in that case, how do we think about lit and the difference between what we already interact with from a wallet perspective compared to what is then possible, right? As I understand this, there's a lot more flexibility that is possible with lit.
Yeah, great question. So right now at the start of 2024, I think we're at this really interesting point in the industry where we are moving from users having self-custody keys when they want to interact with dApps. Obviously, if you're like using a centralized exchange, your keys are taken care of. If you're buying and selling crypto and you work on just the centralized exchange, the keys are managed there. But if you actually want to use Web3, use decentralized applications, use Uniswap, use decentralized social media, etc., the requirement is that you have a key that is associated with you as an individual. And so to date, that key has come in the form of a 12-word seed phrase where the user takes on the responsibility of basically being their own bank functionally. And so the capability that is enabled by having a distributed service manage keys opens up a couple opportunities, not the least of which is being able to replicate a Web 2 style interaction around login. So sign in with Google, use passkeys, email, SMS, authenticator apps, multi-factor authentication that combines those various authentication methods. So from like a user who wants to interact with Web3, that's one of the main benefits. But then one of the really other interesting things about Lit, it has the same property of Ethereum in that it is programmable. That key can also be programmed. So there's some ecosystem partners who are doing things like automated copy trading with the user's key. So a user can say, I really like the way that this account is buying and selling tokens. I have a bunch of tokens in my account. I just want to set up an automation that will copy trade based on this other person. And because the signing is governed by this program, that individual can be, asleep or offline and just doesn't have to interact. And the signing is happening automatically for them.
Right. I think there we get to kind of a third component of Lit protocol as well. We talked about the key management, the signing, and thirdly, what are you automating? That Lit action seems to be a third component that we store in IPFS. So then when the conditions are met, they can actually automate these actions, which can be a combination of on-chain, off-chain as well. You could decrypt things, you can start to sign on-chain transactions or even trigger off-chain actions.
That's right. That's exactly it. That's the name that we call these programs, Lit actions, that are running across this network that developers are articulating, that are essentially governing when a given key pair will decrypt or sign something. And it's certainly very interesting in the world of digital assets and signing transactions, but that's not the only case of signed data. There's also things like verifiable credential issuance, cross-chain messaging, pulling data from off-chain, putting it on-chain, kind of similar to an oracle that is can be used around private data. So where we've seen most of the focus has been certainly around the transactions and user wallets, and basically Lit as a base layer for user wallets. But yeah, certainly the open programmable nature of it is like a generative canvas, and there's a lot of room for product experimentation.
So could I try to clarify this with a few analogies? Right, I think when we talk about the first bit on the signing and the key management, then that feels more like a UI UX improvement whereby we don't have to hold the private keys. Here's social login equivalents or various factors that can various off-chain or Web 2 mechanisms that can verify that you have the key or that you have the credentials. And then the other bit with Lit actions would be more like kind of Ethereum, kind of like having smart contracts, but not necessarily on-chain. It can also be triggered by or used to trigger off-chain and on-chain actions. So I almost feel that we're kind of extending the powers of a blockchain or the cryptography that's related to blockchains to the wider Web 2 world, and also helping blockchains interact with the Web 2 universe through this key management plus automation system.
Yeah, I think it's very apt to kind of like draw the similarities between Lit actions and smart contracts, certainly. Whereas smart contracts, as are computing over state, the actions are dictating the compute that dictates the signing, kind of coming back to that view of, at a fundamental level, we really only have two things in the world of digital ownership, which is state and signing. And so what we're talking about here is programmable signing with the actions, whereas smart contracts are programmable state.
Perfect. Now, let's dive into some use cases to make it real. I know you've mentioned plenty of them already. In fact, there's one that was really high profile that was announced recently, right, with the Fox R&D division. And I thought that's such huge news and would be great to propel the adoption, perhaps, of these Web3 related technologies with many of these Web2 institutions as well. Could you dive into that specific use case? Which parts are using Lit And how could this look like integrated with the rest of Web3 when they're ready to tokenize and put on chain some of their assets as well?
Absolutely. Yeah, it's definitely a really exciting project. And, my compliments to the team at the Blockchain Creative Labs, which is the blockchain division inside of Fox Corporation, for really, frankly, visionary work. They approached us several months ago and said, here's what we want to do. And what their plan was is they said, okay, we see that the AI LLM future is coming and that LLMs are going to want to digest news articles. People want to syndicate news articles. And so I think they've done, which is like great kind of network Web3 oriented thinking, which is to say, we are providing a service today, right? The service that they provide today is their publisher. They publish content. What is the service that...
So to be clear, this is the Fox Giants.
This is Fox.
Publishing.
Fox is a publisher. Yeah. Yes, exactly. Fox, major publisher. And so what was very visionary about their approach was to say, okay, what is the lower level thing that us as a publisher can contribute to? What is the underlying protocol? And that's functionally what they've invented with their Verify Media project. And so what it is specifically, it's basically two components. One is when any given publisher, not just Fox, it's an open network. When any given publisher who's using the system publishes some new content, let's say it's an article, for example, when that article gets published, they essentially read a transaction to chain to create history of when that article was published. And that creates the provenance, that creates the authenticity. That just uses a blockchain. The other really major part of it is the part where they're using lit protocol, is the article itself is encrypted with lit and then uploaded to IPFS. And then it has certain rules around who can decrypt it. And those rules are based on on-chain data, purchasing of assets in order to get access to this. And so essentially, like if you think about the way that news works today, you have like publisher A, publisher B, publisher C. They all have individual relationships with each other where they're syndicating content to each other. This network essentially replaces those individual relationships by saying, okay, everybody just publish to this one source. It's open, it's decentralized, nobody's in control of it. And then any given party can syndicate content from this let's call it like a news pool, or this, that for them, it's the Verify Media protocol. And what is particularly interesting and exciting about this is the way that they've set it up to be read, such that people can decrypt that content and read it, certainly by like other news organizations and individuals, but also by LLMs, also by essentially AI bots, which is very exciting to kind of imagine a future where, let's say an individual subscribes to 5 different media organizations, or like maybe 3 media organizations and 2 creators that they really like. They subscribe to these people and they wake up in the morning, they drink their coffee and they type into their LLM, like, give me my daily briefing. And the LLM bot, because it knows that the user is paying for those articles, will get the decryption rights, will be able to read them from this open protocol, ingest them, and then print out, here's what's going on in the world for you today, based on your interest, based on your subscriptions for that individual. So yeah, that's really quite exciting. And there's certainly more stuff coming there too, with Fox. We really like working with them as a partner.
So for Fox, why do they value the decentralized key management component? Because presumably they can be decentralized access management verifier, where, hey, you purchased or you bought the subscription, therefore I will decrypt it for you, right? Or same with LLMs, so they could verify that, hey, this LLM has paid, and therefore I will decrypt it for you. So why do they want to make it a protocol?
Yeah, I mean, that's a good question for them, but I can take a guess at it, which is like, the era that we are in is the open network era. I think we have, like, I don't want to speak on behalf of them, but I think they can see where the ball is going by like looking at Ethereum, looking at the blockchain world, and seeing that open protocols have pretty unique dynamics when you release something out into the world that it's not a company, it's not an individual, it's not an organization, it's not a nation state. It's this different type of thing. It's a network. And networks, especially like tokenized networks that provide services, to individuals, to developers, whatever it might be. I think that's one way to characterize just Web3 crypto in a broad sense, which said another way is like networks provide services, some commodity, whether it's signing, state, access to news, whatever it might be. And by virtue of being an open network, you get more creativity, more participation, more openness. It lets you work with competitors in other ways that you couldn't if you were a central controller in any given system.
So it sounds to me like they're trying to be even more neutral so that they can attract more third-party content to be on there, and almost use the content as a primitive where, hey, this LM wants to use it in some ways or another, combine it, use it to train, and you can always trace that by like, hey, we decrypted it for this particular, or we use that to trigger this particular action, right? So I think it's, again, coming back to the blockchains and smart contracts and assets, it's almost like whatever data is now kind of tokenized in that sense.
Right.
And whatever interactions can also be automated, similar to smart contracts in that sense. Although not all of those will be on chain.
Yeah, I mean, I think it's like public companies that are leaning into composability at this moment, at the start of 2024, seems to be like quite a thoughtful take, right? I think it's very much seeing where the ball is going and recognizing that something that you produce, whether it's a state or a news article or whatever it might be, that can be used as a component in other systems. And so that's one of the benefits of building open networks.
Mm-hmm. Well, one difference between data or content with assets that are on chain is that assets are by definition exclusionary, right? So if I have an asset, then you don't have it. Whereas if I read a certain piece of content, it can be copied or rebroadcast in some sense. So how do they think about it in this particular use case? How is that dealt with? Because you can imagine somebody who could then like access it and then repackage, resell, or presumably if an LLM has purchased it once, then as many people ask for queries that need to access the same content, they don't need to decrypt it again, right? So in essence, they pay for it once, they know it, and then they can go and use that knowledge elsewhere.
Yeah, I mean, I think it's the exact same way any media organization would handle somebody, buying a subscription to the New York Times and then syndicating it out on Twitter, right? Like just because it's using open systems, the regulation around licensing doesn't stop. So we kind of fall back to those systems. We're all still existing as like economic operators within a lawful economy.
Sorry, I know I took it a bit on tangent. But yeah, it also reminds me of like even with blockchains, right? Even when it's so absolute and there's a source of proof on chain, there's also the idea of like, hey, social forks and hard forks of like, hey, there is always some subjective element of chain culture and so on that we have to I guess like either enforce socially or in some cases regulatorily with the licensing.
Yeah, all of these systems exist in the world. Totally.
Right. Now, moving away from this specific example, and I'm trying to paint like a more comprehensive example then to make it even more clear. I know it's probably going to take many, many attempts for people to understand. In the future, right now, we see the current state of crypto. Well, pardon the pun. Where now we sign transactions. Sometimes we have certain MPC wallets. There are some semi-custodial wallets using MPC, right? And people might know that some elements are interacting off-chain. For example, NFT store content, maybe on IPFS. Some part of those might be programmable as well. Or they can just point to a website, and the website can do whatever. Now, in the future where lit is pervasive, the use of lit protocol for both signing and state is pervasive throughout crypto, throughout Web3. How does that change all of the experiences, the daily things that we're used to seeing right now, from interacting on chain, the assets that we're using on chain, the new kinds of assets and how they can be used on chain, just that new combination?
Yeah, I mean, I think the programmable nature of a key pair that is decentralized, and which is functionally what Lit is offering, means that, like, to me, this is where the AI crypto intersection, one of the other places where the AI crypto intersection is really going to happen. So we're like already starting to have these agents and helpers and co-pilots in our Web2 apps. And in a world where we have just widespread adoption of programmable key material, I think we'll see the same type of thing start to happen in crypto Web3, which is to say we have agents that essentially are kind of like digital counterpart that are managing our assets and our data. Where it starts to get really wild too is there's a few teams working on like autonomous economic agents. So even outside of an individual's control. So if you imagine like an NPC, a non-player character in a fully on-chain game, what they would call like an autonomous world, somebody could build a bot that's a shopkeeper. The shopkeeper doesn't have to answer to anybody because it's running on fully decentralized rails, and it could, understand what the market price is for any given widget within the game, buy and sell, and so forth. And then, that's kind of like a toy example because it's in a game, but the same thing can extend to just like any given economic interaction.
Okay, so AI agents right now they could possibly interact on chain, and with Lit they can interact both on chain and off chain as well, with a combination
That's
of
right.
factors and automated strategies. Let's try to walk through. Okay, so
The,
yeah.
Oh, sorry. I just want to jump back to the other question. The other thing in terms of like what we're really excited about is just an air gap security model. It definitely like the state of how key material is managed today, especially for folks that are not doing it in a self custody way. There's a lot of things to be nervous about where there's just like many people who are dependent on centralized companies that don't have any kind of like custodian certification or licensing, where those companies are fully in control of the key material by virtue of like running things in a trusted enclave. But when you really dig into it, you have centralized companies that are claiming to be non-custodial, but are basically paying the server and could do a denial of service to any one of their users at any point. And so that's the other thing that I think will happen in the future when we start to see more widespread adoption of distributed key management, whether it's culturally from a hack happening of one of these systems and people kind of like waking up to the idea that, wow, maybe don't trust a centralized party with your key material, which is, people who've been through the FTX saga already have the scar tissue around that, for example. But so it may either come from the hack route or from like a regulatory route, which like clearly defines custody as control, both from FinCEN and from the New York Department of Financial Services. So a more secure and more automated Web3 world, basically, in short. But yeah, would love to get to your next piece.
Yeah, no, actually, I love to take this down a little bit more of a
Sure.
tangent. Yeah, so now that we talk about security and air gap, so the source of security in Lit's case, it comes from having this distributed nodes, and us kind of defining the logic of like when and how these key shares can then come together. Correct?
Yeah, it's twofold. So like the notion of there's a notion in security thinking that's called defense in depth, which basically means layers. So there's different types of attacks, and so therefore you have different layers in any kind of given security setup, such that each of those layers are preventing certain types of attacks. So the primary, or we can call it like the first layer, is exactly as you mentioned. Rather than having one company hold a key or key parts, we have a distributed network that is managing these key parts, such that none of them are in control. And it uses something called a threshold crypto system. So in a 30 node network, there's a 2/3 threshold, which is 20 nodes. So that also builds in the fault tolerance, which means like there's a solar storm or somebody forgot to pay their bill or some other mistake happens, the service is not interrupted. That buffer zone is built in there with that extra 1/3. So that's layer one, which we'll call decentralizing the keys or distributing the key shares. And then layer 2 as an additional security method, largely around collusion resistance and prevention. And this is very, very interesting in the world of MPC, because there's some people, us included, I think have kind of started to lead the way on this, that have taken a very hard line that says really the only appropriate way to do distributed key management that like honors the users with the trust of saying, I'm going to store my keys in this system, is to have this second layer of using trusted execution environment. Lit, for performance reasons, and security reasons, uses something specifically called secure encrypted virtualization. Currently, it's a product offered by AMD. So we built a specific operating system for that hardware, which essentially turns that computer into a black box, meaning that the node operator themselves cannot get into that machine to pull out that key material. And so you have an MPC setup that is not using this type of secure hardware. Those node operators can get right into that box and pull out the key material. And so that's kind of the nature of the security model within Lit, this multi-tiered defense in depth strategy.
So when we talk about security, two other concepts come to mind. One is economic security. The other one is, of course, zero knowledge proofs, right? And I think we start to see that, for example, with EigenLayer and AVSs, you can almost kind of trust the small groups of people to then execute. So they could be signing things as well, or they could be executing certain programs with their crypto economic stake of stake ETH, right? Which can be slashed if they misbehave. On the other hand, of course, we have the ZK world trying to prove everything was executed correctly. How do these approaches also interact with Lit? I presume we could somehow layer it on or use it for different use cases here.
Yeah, totally. So, like, let's take those one by one. In terms of economic security, basically the nodes in the Lit network, they are staking, but not necessarily to secure the key material, because the security is like from top to bottom, fully cryptographic. And that's by design, to not depend on economic security, because if you're a big success and you're doing key management, you don't want to get to a place where it goes, oh, wow, the assets held in across these wallets is now greater than the economic security amount. Like, that's a failure state. So the economic security aspect is less around the security of the key material, but more around securing uptime and performance. Basically, people are, like the node operators, are putting up a stake as collateral to say, I'm going to keep my node updated, I'm going to pay my data center bill, etc. But it's disconnected by design from the sanctity of the key material in terms of keeping keys safe. So I just want to mention that. And then on the other side, we have ZK proofs. And I think we can expand this broadly to maybe programmable or verifiable cryptography. So the route and the architecture around Lit, which is MPC, TSS, the dividing up the keys, and also running everything inside of encrypted virtualization, can generate a proof. So like Lit is a fully programmable cryptography network through and through. The difference is the output is a signed message from this network versus a proof that one can verify themselves. But in terms of how they are used in a given program, they are functionally the same. One of the things that has been pretty interesting and exciting is to see what the curve looks like around use cases of proofs, where things are like in blockchains, doing ZK rollups and ZK modularity makes a ton of sense, because you have this built-in computer to be able to verify the state from the L2 or 3 or 4, whatever that is on top of it. But for non-state use cases, things like identity, things that are more focused on an individual, things that where the compute cost of doing a ZKP makes a situation untenable, the trust model of Lit, which is MPC TSS plus the TEE, creates the same thing at significantly less cost. And so it's been really cool to kind of watch developers and product people and startup people and engineers think about, well, should I use a ZKP here, or should I use a signature from lit to act as the proof.
Now, of course, the more tools we have in the box, then the more flexibility the developers have, right? And in this case, to interact with, again, right, things that are Web 2.5, Web 2-ish, right? Things like identity, which are not necessarily on chain, then lit can come in really handy.
Yeah, and maybe I can just mention one more thing related to proofs that is quite interesting. So we were talking a little earlier about this notion of lit actions, these programs that can govern the signing. There's a specific route that one can take with this, because you could think of these as like serverless functions or Lambda functions. That's what these actions are, where the output is some signed data or some decrypted data. And so one of the things that's really interesting is developers have the ability to lock the code that is running to make it unupdatable. And so it essentially becomes like an immutable function, an immutable serverless function. So you could write a function that says, is this number prime? Send numbers up to it. And you have like a cryptographic guarantee that that code is not going to change. So there's elements of immutability that are also really exciting that you don't have in Web 2 serverless function offerings.
Right, and that stems from the property of IPFS itself, right? Which then guarantees that, hey, based on this CID, then none of the content has been changed, and even if you do, then that you can have versioning from there that is global.
That's right.
Perfect. Yeah, actually, I think this would be a good segue to start to talk about the roadmap, right? We talked about then the security, right? Having nodes, having staking, and then interacting with these other components. So as I understand now, our V0 is coming up, and there are many things to look forward to. I think having these nodes, right? Having that roll up. So let's talk about what can people expect and what can we be excited about from a developer perspective, user perspective, so on.
Absolutely. So yeah, the V0 is out. The public announcement is coming soon. We'll probably do one update at the end of February for V0.1, and then the next update will be the V1 later this year, which will use the actual token. The V0 uses a testnet token. And then so the V0 is when the token economy will be part of this, and the supply side will essentially like generate protocol revenue for serving, signing, and decryption from this network. So certainly that has a lot of exciting aspects of it. The other things that are on the roadmap is we have some exciting, like majorly exciting performance improvements in the near-term roadmap that will likely be part of the 0.1 update in terms of the throughput of the network. We have some scaling improvements as well that we're excited about. Just from working closely with developers over the past several years, we have some SDK updates. For example, we're cleaning up the way that authentication is handled, unifying that in the context of the SDK. And then the last piece of the near-term roadmap is integrating more signing curves. So today, the curve, which is called ECDSA, that is supported by Lit for signing, can talk to chains like Bitcoin, Cosmos chains, EVM chains, because that is the signing curve picked by those specific networks. But things like Solana, Aptos, Sui, the Move chains, they use another curve. And so we're integrating those other curves. And we essentially have like a roadmap of curves that we've prioritized by use cases. A lot of them initially are focused on blockchains and wallets and transactions. But also in that roadmap are curves for credential issuance to be used by governments, credential revocation, NIST curves, which is the federal government's standards organization, such that for non-blockchain folks that want to use distributed key management, they have a curve that ticks the box in terms of the standard from their compliance department. And so, yeah, the roadmap is quite kind of cryptography heavy there. And there's one other thing that we are working on. I can talk a little bit about. We haven't talked too much about it publicly yet, but is the notion of domain wallets. There's a few teams that are experimenting with this right now, and this is a very interesting product, and I think potentially solves a lot of Web3 UX issues, and not just like first order issues around where do I store the key, but second order things around like, how is my wallet portable? And we've seen some kind of providers of wallet as a service say, hey, our wallets are portable, but kind of not really, right? It's only like portable provided two dApps are using the same SaaS provider. That's not the portability that we're talking about in Web3. When we talk about Web3, we're talking about one login for the entire internet that you can take to any given dApp and use and sign in with. And so we're working in that direction. And the insight there is to essentially take a crypto domain, so like .eth, unstoppable domains. We have a domain that we're going to kind of demo this with, lit.id, and essentially merging it with a key pair. And so crypto domains today, essentially what they can do is they can receive funds, which is really awesome and a great use of smart contracts. But where we're going when we kind of combine domains with key material in this domain wallet construct is the domain as like a singular account object for somebody who maybe is interested in Web3, but not listening to this podcast and not really deep in it. That account object that combines the domain, making it human readable, and the key means that they can use the same information, like, my ENS is Snyder.eth, for example, to both receive funds, send funds, and log into dApps. And that's something that we're definitely really excited about, and we'll be sharing more broadly soon.
Nice. Yeah, actually, this reminds me of Vitalik's writing about making Ethereum cypherpunk again. And he mentioned various parts of the stack, right? And of course, from like the banking to the receipts to, of course, the DNS, the email, the sign in with Ethereum, and then of course publishing and social media and so on. Yeah. So now we're starting to touch on many parts of the stack. Actually, where would we say Lit stands in that cypherpunk stack, so to speak?
I mean, I think Lit is really a deeply cyberpunk project. There's it answers a philosophical question that has been kicking around in certain circles for years, which is, can the internet keep a secret? And basically we're saying, yes, here's how, by using MPC TSS, the latest in secure hardware, to essentially create a threshold network that's highly performant and can manage millions of keys. And so going back to the way we started the conversation, it's fundamentally a new primitive, distributed programmable key. And I think we're just at the start of seeing how much agency and control that gives back to individuals by being able to depend on a network rather than on a company.
Love that. Can I come back to the tech side and ask a few kind of more lightning-ish questions and more like the design choices? One is, I see that we're planning to have a roll-up and we're using the OP stack, and it says anchored on Polygon, which I'm trying to understand what it means. So firstly, why do we need it? Why roll-up, right? Instead of, say, AppChain or other setups? I presume it's a different rollup. It's not one where people deploy all sorts of DeFi contracts on there and so on, or maybe I'm wrong. and why did we pick this particular stack with like OP, and what does anchored and Polygon mean?
Yeah, absolutely. So I mean, that was part of the testnet. I think where we'll end up for the V1 in terms of what the blockchain stack associated with Lit protocol looks like. There's still some investigation that's ongoing there, but the heart of the question is a great one, which is like, okay, cool, you've got these signing nodes. What do you need a blockchain for? And basically, where we kind of landed in designing and building this thing goes, wow, the nodes need a way to communicate with each other, and users need a way to associate authentication material associated with a given key. It seems like we need a database to make this system performant, to make this system work. But it would be really great if this database was like immutable and also public. So it's quite obvious to use a blockchain. But you're absolutely right that this is essentially like the blockchain, the L2 that Lit is using. I think we can call it an app chain. That's totally appropriate. The Lit app chain basically enables the rest of the nodes to be able to provide the service. And because the supply side, these nodes are these distributed parties who don't necessarily have relationships, certainly don't have legal contracts with each other, anything like that. That becomes the area to coordinate and to check information from. And we've also added a lot of really interesting customizations into the lit chain. It's called Chronicle. A lot of precompiles for using the sophisticated cryptography that functions across lit. But in short, it's just a place to store information.
So, yeah, the interesting thing about this rollup is that for other rollups, they tend to use ETH as gas, right? But with Lit, given the more kind of app chain approach, we're using Lit as gas. Why do we decide to do this? And I know that, like you mentioned, there were quite a few examples of that being done. But in this case, especially for the user, if we wanted to make it really intuitive and for a simplistic UI UX where they don't have to acquire a new token, how do we address that with Lit as the gas token?
Yeah, absolutely. So Lit, like Filecoin or Chainlink or Ethereum, is a network that provides a service as a commodity and therefore has a digital commodity token associated with it. And so developers are consuming the service, and then they basically can, using signatures, can grant the ability to their users to leverage the system. So if you think about the Web 2 stack, when Dropbox first launched, users paid Dropbox some subscription fee, and Dropbox then paid AWS credits to leverage the underlying compute and storage. Same setup here. Developers consume Lit, and then those developers and product teams have their customers and that interaction.
I see. Makes sense. Yeah, increasingly we see more of this abstraction happening between the user and the infrastructure. It used to be that like, hey, we're having our own private keys. We need to get our own gas, and we're signing transactions and directly to the DeFi primitive protocol. But here, I think we start to see, hey, you interact through a rollup, interact through a signing service, you interact through MPC wallet. So more, and you don't have to define the network, define the gas, and so on. So more and more things are getting abstracted away. That's very much our thesis here at LongHash Ventures, where we talk about the multi-chain infra or the modular thesis, whereby then you have different layers that will service these different needs. And some of them will be app chains that are application specific. Some of them will be app chains which are more like modular functions, right? Which can relate to things like data availability or ZK proofs, or also in this case, signing. So I'd love to now zoom out a little bit and think about then the longer term future. How do you see this all playing out? It seems to already be happening in front of us, right? This explosion of modular layers and app chains.
Yeah.
How do you envision this space will transform in the coming even just 1 to 3 to 5 years?
I mean, I think we're just getting started. Like the where to dive in. There's just so many places. Certainly we're like seeing new types of applications emerge. I mean, maybe we could just like point at a couple examples just to illustrate how early we are. So for example, in like blockchain games, especially like the on-chain game component, right now in games, there's no notion of information asymmetry, which is to say everybody has all of the same information, which is great. It's created some cool kind of fun games to play, but it's really missing a strategy element, because if you think about any good strategy game, the whole idea is that, like in a card game, for example, I can see my hand, but you can't see your hand. And like, that's just one example from gaming that like, we haven't really even gotten started to an extent yet. Another example would be around the world of verifiable credentials and user-owned data, storing information either like on device or backing it up on IPFS-based systems that gets encrypted. We see a lot of people using Lit to encrypt data in that context. That's kind of happening, but still so early. Like as an illustration of how early it is, we haven't even kind of come to a standard on what a consent view looks like. And what I mean by that is just talking about user-owned data. People probably have had the experience of clicking sign in with Google and then seeing the screen that says, this app wants access to your contacts and calendar, something like that. That is like now possible to do as a first party relationship between the user and their data and the website and the application. And there's a handful of teams and there's a lot of really brilliant people working in this space but that is really also at its infancy. We've obviously seen like an amazing explosion of decentralized finance, but as I guess another example of how early we are is there's not really a lot of quality of life tools. So let's say you're an LP on a DEX. Like, how do you not get liquidated? Well, you have to sign up for an alert, and then if you have this token pair and one of the prices drop, you like get a text and you have to run to your computer and pull out your ledger and make sure that you bolster your position such that you're not liquidated, right? Like, we don't have automation around that yet. Those type of things are coming. We've seen those type of things being built with Lit. That's really exciting. So we've certainly come a long way in the past decade and a half, roughly. But I think there's just a lot of room to grow. We're just seeing more and more innovation in the world of programmable cryptography as well, which we're really excited about because a lot of those new primitives will require threshold systems. And then, 5 years, where could this be? It's a really fun prompt. I think, some of it will depend on regulation, certainly. Certainly there's like those, at least in the US government, that are quite adversarial to what's happening here. But I think that as soon as, going back to the second point around like the user-owned data, as soon as there's like more clear examples, especially at a larger scale, around how beneficial it is for somebody to own their own data that uses decentralized rails, I think we'll see states like California, which have passed the California Data Protection Act, and the EU with GDPR, actually seeing what a lot of people already see, which is that the decentralized system is one that provides more control to the user. Folks at the Department of Homeland Security are really interested in this type of thing, for example, as it relates to verifiable credential issuance. And I think over time, the understanding will emerge, especially maybe from like a regulatory point of view, is that in order to have these systems that provide control and protection to individuals, which is, I think, something that everybody wants, and is pretty universally agreed upon, except for, the powers that be that are currently holding on to the control, is that we will start to see these networks for what they are, which is that they're open networks. If people want to participate in them economically, they can. There's no stopping them. And yeah, kind of the way that I think about it is like, if you've ever been to a classic kind of startup tech office versus a corporate office, let's kind of use these examples as Web 2 and Web 3. If you go to a normal corporate office and you look up at the ceiling, you see the roof. But like the classic trope of the startup office is you see the pipes exposed and they're all different colors, and oh, there's the electricity and there's the heating. And that's kind of, it's maybe a rough metaphor, but that's kind of the difference between Web 2 and Web 3, which is like, because these are open systems, you can see into them, so to speak. You can look at explorers, you can see what the price of the token is, etc. And that's just the nature of our new system, is that it is open.
Love that, right? And especially, it's not always that we want to see them or we want to actually tinker around, but having the option of going direct is important, right? So that we can take back ownership and responsibility if we choose to do so. And if we choose to give it away, we can choose to do so, rather than only having one option today. So I want to start to wrap up. For a builder or a person trying to get involved in the space who's excited now, hearing about all this vision, all these possibilities, how can they, maybe perhaps some words of advice or sharing from your journey, David? It's been multiple years, like you said, going through the idea maze, building out Lit, multiple versions, there's different features, launching, and of course on the business side, fundraising, getting use cases, right, advocating and going to all these events, hackathons, so on. What have you learned? What would you like to share?
Don't overthink it. Is in short, like, I would start, if somebody's really excited about this but they're unsure of what to build, probably the first thing to check out is this really wonderful book called The Mom Test. It takes 2-3 hours to read, super easy to consume. And the general premise of this book is that everybody is lying to you, which is to say, if you have this big idea and you go to somebody, you say, hey, here's my idea, what do you think about it? People are generally nice and will say, that's great idea, I can't wait to use that. And like, that's a trap from a product oriented thinking. the real kind of insight comes from, how can I understand what this person is doing? What is the job that they are trying to accomplish? And really becoming like a student of whatever your specific focus area is, whether it's social, whether it's DeFi, whatever it might be. And yeah, just recognizing that there are many, many cool ideas out there that actually aren't valuable. And the heart of it is being able to like get conviction internally to say, this seems like something that I would be excited about spending 5-10 years on building out, because from talking with other people, I have confirmed and validated that this is something useful and interesting to them, not because they told me, but because I can see and understand how they live and how they carry out their day and what their goals and dreams and aspirations are.
Perfect. Yeah, and that's how we can give users something that they didn't know they needed, because we see that the real pain points and the behavior that they're going through. Lovely. All right. Now, finally, for people who are interested to get involved with Lit, be it, say, eventually running the nodes or building something or trying out many of the products, where should they find you or find more about Lit?
Yeah. The website's litprotocol.com. At the bottom of the page and elsewhere, you'll see the developer docs. There's a contact us form for node operators. We're still in that phase right now. And yeah, also the careers tab and the jobs board is there as well. We're also super active on Twitter and on Farcaster protocol. Really easy to reach. Discord is another great place to get involved. So yeah, please get in touch by any means.
All right. Any final parting message you want to share with the audience?
Yeah, I mean, I guess I'll just come back to where we started, which is to say that like we're really at the beginning of this thing as kind of moving into a world where people consume services from networks. And I know that like right now we're in an exciting time. I've been in this industry since 2017, as I mentioned. Like things go up and down and up and down. And I would just kind of put forward one idea, which is that I think a lot of us, myself included, kind of got locked into the idea that, oh, a new thing comes out and, just like ChatGPT, it should have 100 million users after 30 days. Why isn't that happening in crypto? Why isn't that happening in blockchain? And that is a dynamic that was established by the social media companies. Snapchat came out, grew faster than Facebook, et cetera, et cetera, et cetera. I think a lot of people have seen the graph that I'm referring to. But if we really take a step back here and say, like, what is happening now? Where are we at now? What is really happening is really more about the evolution of compute and the maturation of the internet. And these are things that are happening on decades-long time scale. It took a half a century for computers to go from the size of a room to the size of our cell phones that fit in our pockets. And so decentralized compute is on that same trajectory. And so just kind of like holding the long view in the midst of what can be kind of like a crazy industry where there's a new trend here and a new trend there, and it's all really, really exciting stuff. Just making sure that one holds in mind, like, what is actually happening here. We are upgrading the internet, and in turn upgrading civilization and society that is so dependent on the internet.
Perfect. And on that note, thank you so much, David. And please reach out.
Thanks, everybody.
All right.